This is a multiple-choice question about the TF-IDF vectorizer, a tool we use to convert text into numbers that machine learning models can understand. It tests your understanding of how the vectorizer works and its various settings. This question asks you to identify which statements about the TF-IDF vectorizer's parameters are true. We'll analyze each parameter one by one. Think of it like a quiz to see how well you know the settings. This section introduces the main parameters of the TF-IDF vectorizer that the quiz covers. _ngram_range_, max_df_, _sublinear_tf_, and _stop_words . Let's dive into each one. These settings control how the text is converted into numerical data. The _ngram_range parameter determines what size of chunks of words the vectorizer uses. For example, _ngram_range equals 1, 2, means it considers individual words, unigrams, and also pairs of words, bigrams. I think of it like changing the grain size of the text. This parameter controls how frequently a word must appear across all documents to be included. A higher value means only words that appear in a large portion of the documents are kept. I think of it like setting a filter to remove words that are too common across the dataset. This is all about how strongly frequent words affect the TF-IDF score. Setting _sublinear_tf equals true lessens the weight of frequently occurring words, preventing them from dominating the analysis. Think of it as a volume control for common words, reducing their influence. It's a smart way to keep things balanced. I use this parameter to remove common words, like the, is, that don't usually add much meaning to the analysis. Setting _stop_words equals English, automatically uses a list of common English words to remove, cleaning up the data. I think of it as removing the clutter to make the important words stand out. It's like removing background noise. I understand this section describes the overall topic. We're diving into the parameters of the TF-IDF vectorizer, a tool in sklearn, a popular Python library for machine learning that transforms text into numerical data usable by machine learning algorithms. Think of it like translating a language humans understand, words, into a language computers understand, numbers. This is the core question. We're asked to identify true statements about different parameters within the sklearn's TF-IDF vectorizer . We need to carefully examine each statement's accuracy. This statement says that setting _ngram_range to 1, 2, includes both single words, unigrams, and pairs of words, bigrams. For example, if your text is, "This is great," unigrams are, "This is great," and bigrams are, "This is great." This is absolutely correct. This statement is incorrect. Max_df controls the maximum number of documents a word can appear in to be included in the vocabulary. Increasing it actually reduces the vocabulary size because more frequent words are kept. The statement correctly explains that setting _sublinear_tf equals true uses a logarithmic scale for term frequencies. This means words that show up frequently won't have as much weight in the final TF-IDF score, which prevents very common words from dominating the results. That's correct! ! This one's true. Setting _stop_words equals English, will remove common English words like the, and is from the analysis. These words usually don't add much meaning to the overall sentiment. This instruction reminds us that multiple answers may be correct. We need to carefully consider each option and select all the ones that accurately describe the TF-IDF vectorizer parameters. I see this as the title of the section, introducing the topic of understanding parameters within the TF-IDF vectorizer. It sets the stage for the questions that follow. This line simply introduces the multiple-choice question about the TF-IDF vectorizer and its parameters in sklearn, a popular Python library for machine learning. This is the actual multiple-choice question. It asks you to identify true statements regarding the parameters of the "TF-IDF vectorizer". It's testing your understanding of how these parameters affect the vectorization process. This option explores the "ngram_range" parameter. The "ngram_range" parameter is how you tell TF-IDF to consider n-grams. 1, 2 means include both single words, unigrams, and pairs of words, bigrams. I will need to determine if this is correct. This is about the "max_df" parameter, which controls the maximum proportion of documents a word can appear in to be included. A higher "max_df" means less words are considered, resulting in a smaller vocabulary. I'll need to assess if this statement accurately reflects its behavior. Here, the question focuses on "sublinear_tf". If I set "sublinear_tf equals true", TF-IDF uses a logarithmic scaling of term frequencies. This lessens the impact of extremely common words. I will assess if this claim is accurate. This option discusses "stop_words". Setting it to English. Removes common English words, like the, a, is. This helps focus on more meaningful words. I'll check if this is true or false. This line simply labels the set of options provided in the multiple-choice question. It's essentially a header for the possible answers. I see this as the core process. We're taking text data and converting it into numbers using a method called TF-IDF. Think of it like translating words into a language computers understand. TF-IDF stands for term frequency inverse document frequency, and it calculates how important each word is in a document compared to the entire collection of documents. This is the output of the TF-IDF transformation. We end up with a bunch of numerical vectors. Each one represents a single document. Each number in the vector represents the importance of a specific word in that document. This is about the parameters in the TF-IDF vectorizer and how they help you customize the transformation. These parameters let you change how TF-IDF works. I'll explain them below. This section presents the actual questions about how these parameters affect the process. It's a multiple-choice quiz to test your understanding of how these parameters affect your results. This question asks you to identify which statements correctly describe how the TF-IDF vectorizer in scikit-learn works. We'll examine each statement carefully to see if it's accurate. Let's get started. This is the overall theme. We're diving into the parameters, the settings, of the TF-IDF vectorizer in scikit-learn. I'll explain what each setting does and how it affects the process of turning text into numbers that a computer can understand. Remember, TF-IDF stands for Term Frequency Inverse Document Frequency. This method is used to represent text as numerical features based on how often words appear in a document and across all documents. This statement says that setting "ngram_range" to 1, 2 will consider both single words, unigrams, and pairs of words, bigrams. I confirm that this is absolutely correct. For example, with the input sentence, "This is a sentence," the vectorizer would consider, "This is a sentence," unigrams, and also, "This is a sentence," bigrams. This one is tricky. The "max_df" parameter controls what words are kept. Increasing it keeps words that appear in a larger fraction of documents. Therefore, a larger "max_df" actually reduces the vocabulary size. I've found that this is incorrect. I'll explain this carefully. "sublinear_tf equals true" changes how the frequency of a word is calculated. Instead of using the raw count, it uses a logarithm, so very common words have less impact on the overall score. This is correct. This is another correct one. Setting "stop_words" to English tells the vectorizer to ignore common English words like articles and prepositions, which are often not important for sentiment analysis. This simply means to choose every statement that you believe to be accurate based on your understanding of TF-IDF and its parameters. I'll explain the parameters of scikit-learn's TF-IDF vectorizer. a tool we use to turn text into numbers for machine learning. It's all about understanding how words impact the meaning of a document. We'll look at how different settings change what the computer sees in your text data. This parameter controls how common a word has to be included. A higher max_df means I only keep words that appear in a smaller fraction of documents. Think of it as raising the bar for word inclusion. Only the really important, not so common words make the cut. This reduces the vocabulary size and keeps only distinctive words. This tells the vectorizer what kind of word groups to consider. 1, 2 means I'll look at single words, unigrams, and pairs of words, big rams. For example, artificial intelligence would be treated as two separate features, artificial and intelligence, but also as a single feature, artificial intelligence. I use this to lessen the influence of words that show up super frequently. If you set _sublinear_tf equals true I apply a logarithmic transformation to the term frequencies. That is, the more frequent a word, the less extra weight it gets. This helps prevent very common words from dominating the analysis and obscuring less common but potentially more important ones. I use this to remove common words like the, a, and is that don't usually tell us much about the sentiment of a text. Setting it to English uses a built-in list of these common words. This cleans up your data and focuses on the words that really matter. This question tests your understanding of the TF-IDF, term frequency inverse document frequency, vectorizer in sklearn. I'm asking you to identify which statements correctly describe how its parameters work. These are the settings you can adjust to control how the TF-IDF vectorizer processes text data and creates numerical features for machine learning models. We'll be focusing on 4 specific parameters: _ngram_range _max_df _sublinear_tf and _stop_words . This parameter determines the lengths of n grams considered. For example, _ngram_range equals 1, 2 includes both single words, unigrams, and pairs of consecutive words, big rams. Imagine I have the sentence, the quick brown fox, with _ngram_range equals 1, 2 I'd consider the quick brown fox, the quick brown, and brown fox. This sets the maximum document frequency for a term to be included in the vocabulary. It's a threshold. If a word appears in more documents than this threshold, I will exclude it. A higher _max_df leads to a smaller vocabulary, because more frequent words are excluded. Think of it like this. Words that are too common probably aren't very useful for distinguishing between documents. Setting _sublinear_tf equals true means I'll use a logarithmic transformation of term frequencies. This dampens the effect of extremely frequent words. This helps to prevent the model from being overly influenced by extremely common words that might not carry much meaning. Imagine scaling down the loudness of the most frequently shouted words in a speech. Their contribution is still present but no longer dominates. This parameter lets you remove common words that typically don't contribute much to the meaning, like the, a, is. Setting it to English uses sklearn's built-in list of common English words to remove. It's like cleaning up the clutter before building something meaningful.